Hey, what's up YouTube? Welcome to another video. Today we're going to be re-recording the Coffee API application that we created on the other video in Golang. I'm going to recreate this because the other one was a little bit long. It was a little bit unplanned, so I did it on the go, and that's why it took like 4 hours and something. So essentially I redid it. I added a few improvements here and there. And now that I have it organized and planned, this should take way less. Hopefully it goes below the 2 hours mark, but we'll see. But with further ado, let's go ahead and start with the application. So what we're going to be doing here, as you can see, is start from scratch. I'm going to go ahead and do my create directory. I'm going to call this coffee app. So let's go inside of our application. I'm going to be doing the following. I'm going to create the server side, but also the client side. Hopefully, this series goes a little bit further and we can also implement the front end, and hence why we're going to be creating both. So first of all, I'm going to do my server directory. So make directory, coffee server, and then I'm gonna go ahead and create my client. I'm gonna use Next.js, install command. So I believe you can just use at latest. Actually, let's go here. Get started. Installation. Yep. So I'm going to do here npx create next app latest. Sure, let's install all the latest thing. What is your project name? This is going to be coffee with double F. And I'm going to put client. TypeScript, yes, yes, and yes. Tailwind, yes, we're going to be using Tailwind. Source directory, yes, I like that. Would you like to use the app router? No, we're going to be using the old router. I don't need to customize any default stuff, import alias or whatever. So that is going to be created and whatnot. Just gonna pause it and what that creates. All right, so there it is. It's created. So now we should be having those two folders, the coffee client and the coffee server. Either way, today we're not gonna be doing a lot of client, or not in this video at least. So I'm gonna go into my mvim and let's start with the server. So the first thing that we want to do is set up our make file, where inside of our main file we're going to set up the Docker container, the database, some commands that we will be using, and make sure that we can have our migrations, our tables, and whatnot. So let's start with that. So the first thing that I'm going to do, I'm going to create my git ignore file. So there's my file. I'm going to ignore the .env, and I'm also going to ignore, let's see if I'm missing something else. Git ignore. That should be fine. Okay, so we have those two things, the file and the git ignore file, the .env ignore and the env file ignore. I'm going to create my .env. Inside of my .env, so this is very important, I'm going to be creating, let me see, where did I leave this? We're going to be creating the following variables. So the first one is going to be the port. Later when we start the application, we're going to be making use of that. Also very important, the Docker container name, which I'm only going to be calling it db docker container. So this is going to be the name of the Docker container, not the database. So YouTube YouTube db container. Then we're gonna have the db name. So this is going to be the name of the database. I'm gonna put YouTube coffee db. The user, root, password, secret. Again, this is not ultra secure, but since this learning tutorial, we really don't care for now. Obviously, when we create a production application, these variables will be more secure. You know, user and password will probably be different. Will definitely be different. The database port will be the default for Postgres. We're going to be using Postgres, so 5432. And the binary, so the name of our compile file will be the following. I'm going to call it coffee _ API. All right, and we're going to be saving that. Okay, cool. So now let's go ahead and create our make file. So here we're going to be putting all the instructions, you know, to create our binary, to start Docker containers, to stop Docker containers, to initiate migrations. Everything will be there. So let's go ahead and start with our make file. So the first thing that I'm going to do is to include the .env file. So we're going to be pulling the variables from there. That way we can add our make file to our repo, but we're not exposing any important information into our GitHub repo. So this is a command that I like to put because I think it's very useful. This will stop any containers that are running. So stopping other Docker containers. So we're going to be doing the following. We're going to be listing any Docker container. And if we do happen to see any Docker container running, then we're going to be stopping that Docker container. So we're going to echo found and stopped containers. And here we'll be doing the stopping. So stop Docker PS, and lastly, if there are no Docker containers running, and actually the echo, we also need to escape it with the following. Otherwise, we'll get some errors if we don't do the backslash. So otherwise, if there are no containers running, we put no containers running. Okay, so we'll do it like that. So let's make sure that this command works. So I'm gonna do make. Oh, I need to be on the server. So cd coffee server make stop containers. And I probably have one error probably here on the echo. I'm missing the semicolon probably. Okay, let's try that again. And there you go. No containers running. Perfect. The second thing that we want to do is to create our Docker container. So create container is going to be done in the following way. I'm going to be doing docker run. I'm going to give it an explicit name, referencing our db docker container. And we can see what we have. Let me see if I can open the... Okay, I'll probably have to do this. There you go. So we have the db docker container. Okay. when we create it, we're going to be designating a port 5432 on our local machine and also on the virtual machine or in the Docker container. Actually, I may need to close this so we have more screen. Okay. So we're gonna set the postgres user equal to the user variable that we have in our .env. Same for the password. I'm gonna have to put postgres password equal to password. And lastly, the type of image that we're going to be using, which is a 12 Alpine Linux image. All right, so we're gonna be having that. So I'm gonna pull up the Docker desktop application, and right now I have no images running. So I'm gonna do the following. I'm gonna run my create container command, and you should be able to see this. So when you see that, it means that you created correctly the image. And here, as you can see, I have the YouTube DB container successfully created. So that is how we create our Docker container. So now what we're going to be doing is creating the database inside that Docker container. So create DB will be equal to docker execute /it, and I'm going to pass the name of the Docker container. I'm going to pass the variable, or the name of the container that we just created. We're going to execute the command create db, and the username will be the same as the one that we use with the user variable. Same for the owner. And we're going to call our database whatever we designated with our db name variable in our .env. Okay, so let's go ahead and make sure that this works. So I'm going to run the create db, and it all seems to be fine. Perfect. So now we just want to make sure that this is actually running. So I'm going to be opening Table Plus. And you can use any software. You don't have to use Table Plus. You can use Postgres Manager. You can use, I think there's Beekeeper Studio, whatever. Whichever database connection manager you want to use, go ahead. But we want to make sure that we can connect. So host by default, that's fine. Port, I'm not going to specify either because the default is 5432. Username root, password secret. The database is the one that we used. The database name is the one that we used. Okay, I have to open it manually. Okay, so YouTube Coffee DB. Okay, so YouTube Coffee DB, and SSL mode we're gonna put disabled for now. So we're gonna connect, and here you go. It's completely empty. We don't have anything, but it is connecting. Perfect. So you should be able to connect. And I forgot to, let me edit this. I'm gonna call this YouTube Coffee server version 2. There you go. So now I have that, and I can easily connect, and we can check that out. Okay, so we have that. So it's working perfect. So now let's move on to the creation of our migrations. Now, something that I also do is I like to put the start containers. So whenever we have this, in development, and we already created our container and our DB inside of our container, we can easily start the container with just the start container command. So actually start container, not containers. This is very easy. We're gonna do docker start, and I'm gonna pass it db docker container. Very simple. So I'm just gonna show you. I'm gonna stop this, and then I'm just gonna run make start container, and there you go. It's up and running again. So it's something useful to have. Now we're gonna go ahead and do create. We're gonna create our migrations. Create migrations, and I'm gonna be using SQLX. Migrate add r init. I'm gonna show you guys what SQLX is. So SQLX CLI. So there's two ways of installing SQLX CLI for people that have Mac OS. Just do brew install SQLX CLI. It's actually very easy to install this way. In the case that you have Windows or Linux, I think you can use homebrew in Linux, but it may be a little bit tougher to do. The other thing that you can do is install Rust with Cargo. And then you can install SQLX CLI with the Cargo tool management. Normally, I don't like to rely in other language related tools, but I believe that in this particular case, SQLX is actually really, really good. So that's why I'm going to be using the SQLX CLI. And this is how we create our migrations initially. So I'm gonna do make create migrations. As you can see, this created a file within our coffee server folder. Two files, the up file and the down file. So the up, as you can guess, is gonna upload the migrations. The down is gonna revert whichever migrations we make. So now that we are in that topic, let's make sure that we have the proper code to create tables and whatnot. And by the way, I'm gonna be putting this on GitHub. That way you don't have to write it by hand, and not because it's hard, but because sometimes you have typos and it can get a little bit annoying if you don't have like the exact wording or the exact code and whatnot. So I'm gonna be putting this on GitHub. So we're gonna be creating the following. We're going to be using UUID. So this is going to be a function that creates UUIDs, and it's just way nicer for Postgres to deal that. You could create it manually within your Golang code, but it's just easier for Postgres to deal with that. So that's why I have it set up this way. So we're So we're gonna set it up like that, and on the down file, we're gonna do the following. We're going to say whenever we want to revert any migrations, there you go. Not here, there you go. Let's put that code. Okay, so we're gonna be doing the following: drop table if exists, and we make a reference to the table. Okay, so now on the make file, so let's go ahead and create our migrations. So we already have the we created the migrations folder. I want to add the migrations. So let me just reference my notes. Okay, so let's start with the migration, the up migration. So I'm gonna do migrate up, and it's gonna be the following. The the code. sqlx migrate run database URL, and we're going to be doing the following. And we could probably put these on the .env, so it is a little bit easier to write, but for now I'm gonna write it this way. If I see later that it's more useful to put everything within the .env, I'll do it. But this allows to make it easier to change the user password and whatnot. So we're gonna do postgres semicolon / user semicolon password. Then we're gonna put the host. So host, there you go. Then we're going to be declaring the database port, the database name, and lastly, if we're going to be using SSL mode, which currently I have it disabled. So I'm going to put disable. Okay. So let's go ahead and test that code. So for this, I just need to make sure that this is connected and I have no tables. So now I'm going to do make migrate up and felt user for root. Probably I have a typo here, so I just want to make sure that I put on the, let's open the .env, user root. So all seems to be fine. So maybe I have a typo here on my URL. Postgres user, yeah, password. I didn't see that. So you probably caught this. So if you caught this, that's good. If not, we can just run it again. And there you go. You see applied. So now I'm gonna go here and we're gonna have we should see, interesting, make migrate up database URL. I'm gonna do my make migrate up again. The possible one reason why this is not pulling this is maybe I did not save it. It's not pulling it's not creating the table. It's because maybe I didn't save it, and that has happened before. So let's see. Interesting. Table root public. Okay, so I mixed this up. Wow. Okay, so let's do the following. This should go in down, and so maybe you also got this. Okay. So this is where the down code goes, and let's delete that. Put that there. Okay. Now this should be working. So what's cool is that it has a was previously planned but has been modified. Okay, so this is a good moment to revert the migration, because it says was previously applied but it was modified, meaning like, you know, the migration has a track of what we did, and previously we had the drop code, so we had that code in it up. So now, well, it's a good time to add the migrate down. That way we can revert migrate. That way we can revert our migrations. So migrate run. No, migrate revert, and we're going to be copy pasting the whole the whole line after the run on line 3, we're gonna put it here. And we're gonna be testing it. So I'm gonna do make migrate down. And it was applied, so now let's do make migrate up. And we should be able to see the table now. And there you go, we have the coffees table. So now we can see that both the migrate up and the migrate down work perfectly. And I guess that's a good example on when do we use migrate up and migrate down whenever we mess up something, whatever. That's the reason why we have the ability to revert migrations. Also, if you want to change them, I mean, you can alter tables rather than like, you know, reverting a whole migration and whatnot. But, you know, it's there if we want to use it. So now that we have that, I know that we have no Golang code whatsoever at this point, and we're gonna start doing that now. So I'm gonna be doing the following. I'm gonna create a command folder, and within that command I'm also going to create a server folder. So that is very standard within a Golang application, and that's because you can have a full stack application kind of like Django. You can have a API also, like we're going to be doing right now, and you can have a CLI application within the same project. So you divide them using this folder standard convention, you know, this naming convention. So that's why you see this command server naming convention. So anyway, within the server is where we're going to be putting our main file, or like the entry point or the execution point of our API. So this is going to be our main package. And for now, I'm going to just be putting func main and fp API is running. Obviously, don't forget to import fmt or the format package. And obviously this is not a server running, this is just like a print statement, but for now we're gonna leave it like that. So a couple of things that I want to add into the make file, and I know that this is very thorough, but this is going to be a really, you know, a good helping hand when we start developing our API. The fact that we have a really good make file will help us in the long run. So the first thing that I'm going to do is I'm going to use a build. And again, I'm going to be doing the following. I want to, this is really not necessary. You can do it manually. Same for the start containers, the stop containers are commands that are nice to have. You don't have to put them. But I think they're really useful because you can just execute it, and the make file will check for you whether a container is running, whether if the container is not running, etc. Same with this. When we start a build process, what I'm going to be doing right now is to check if there's already a binary file existing. So if the binary file already exists, then it's not going to create that binary because we already have it. Sorry, it's going to check if the binary exists. So if it exists, then it's going to delete it, right? So we're going to be doing remove binary, and we're going to echo that. So we put deleted and the name of our binary. But if the binary doesn't exist, echo deleted, let's indent this. Okay, there you go. But if there's no binary already existing, then we are going to create a new one. So no, do I want to put that echo build a binary? I think I'm gonna end the if statement there. We don't need an else, to be honest, because I had previously an if else, but with just the if is more than enough. I will put, however, the echo of building binary, and build Probably I have the if else when I was developing and testing this command, but since I've used this before, I know that this works, so I don't need to use an if else bash script. So I'm gonna build the binary and I'm going to put that in our server. And I'm going to be compiling this from our command server main.go file, because we're only gonna have one main file, but I've seen people putting everything within the server folder, so you can just put the start.go declaration and it will compile all the Go files that are needed to run the application. When we run, we want to make sure that we build a new binary. So when I put this command next to the run, it'll essentially first run this command, then it'll run whatever we put underneath this command. So we're going to put start in. Actually, I don't want to put starting binary build because that's already done. I do want to, once the binary is built, I want to execute my binary and put echo API started. Okay, we also want to put a stop command. That's in case we want to run this in the background, when we want to be able to stop it. So we're gonna be doing the following: echo stop in backend, and we're going to be doing the following: pkill sigterm, and we're going to be pointing to our file, which is the name of whatever we called our binary. Then we can, signal again. Server stopped, and I'm gonna put stop in server. Okay, perfect. So let's go ahead and test our, let me close this. Let's go ahead and test the build. So make build, and we have a syntax. Probably I'm missing this. If then docker containers remove binary. Okay, that's fine. Am I missing fi? Okay. And there you go. So our coffee API is created. Now I'm gonna run again make build, and you probably will see how it gets deleted and then built again. So I don't know if you saw that like quick flash, but that's how you can tell that it was deleted and then built again. So now I'm gonna do make run, and make run runs the command build, which deletes and creates the binary again. And then as you can see here, you see API is running, which is coming from our main.go. And you can also see the API started. I don't know if I want to put API started. I don't know. That shouldn't be printed. There you go. So API is running. Perfect. I don't know why I put that. Okay, so it's working. And make run, build run. Yeah. I believe that's all we need. I have another extra command, which is a start, but essentially is repeating the run one. So there's no need to create another command. That's all we need. Okay, so let's start in our let's start with a Go application. I know we took our time, but believe me, this is a really good and solid base to start with. So now that we have everything that we need within our make file, what we're going to be doing now is make sure that we can start the server. And by that is creating an actual server that listens or opens its port to whichever client's request the server data connection replies and whatnot. So let's start that. So here what I'm going to do is the following. I'm going to create two structs. So I'm going to create the config struct, and I'm going to create the application struct. Now let's start with the config struct. So I'm going to be putting a port of type string, and in the application struct I'm going to put the config of type config. Why do I do this? Because right now we're not going to be doing the addition. So here normally I put models, but we haven't created any models yet. You know, in this case the coffee model or entity that we will be using, but later we're going to be putting this. So it's really easy to do you know, extension methods and getting the properties of the application, especially when you have more models. You can just add more and more, actually they're called fields in Golang. You can add more and more fields inside of the application struct. Again, for now, we're only going to be having config, so it might seem a little bit redundant, but trust me, it's a really good way of organizing your application in this way. So I'm going to be doing the following. I'm going to add a method to the application struct, and we're going to be doing it in this way. So we're going to be adding the method pointing to the struct. So our method will be the surf method, which in return will only return an error. If there's an error, then you know you return the error. Otherwise, you just return a nil error. Now, because surf will be a continuous listening process, you will never return until you quit the application, and when you quit, it'll return nil, or if there's an error, it'll return the error. So yeah, the first thing that we are going to be doing is loading our .env variable. So I'm going to be using go.env.load. And obviously we don't have this installed, but I'm going to be doing an import, and I'm going to write it here, and later I'll show you a very neat trick that I really like. But we're going to be doing the following: github.com, and this is going to be coming from go.env. And as you can see, my Golang server is telling me we cannot import. We can find it on any package. So what are we missing here? So we only have one file, and if we want to start adding packages and whatnot, before I do the importing or downloading of the go.env file, we need to create our module, our Golang module. So what we're going to be doing is, you know, precisely that. Create our Golang module, which we're going to be doing in the following way. Go mod init. And so actually I'm going to be doing this, and you'll see what Golang says. It says like, okay, if you're going to initialize a module, put a name. You can do example.com, blah, blah, blah. So we're going to be doing the following. Go mod init. I'm going to put GitHub. It's very customary to use your username, kind of like you see here. Right? So this person is doing the same, the GitHub, their username, and the name of the project. So I'm going to be doing something similar. So Artur Phil, and I'm going to put YouTube coffee server. YouTube, I'm going to put YouTube Go coffee server. There you go. So now you should be able to see the go.mod, and we don't have any packages, or I guess dependencies you can call them. So I'm going to be doing the following. I'm going to do go mod tidy. And what that does is that if it sees an import here, but it doesn't have the import in the Go mod, it's gonna add it. So now we have it. So that's what I think it's really cool from Go. Okay, so now that we have that, we can do go.env.load. We want to make sure that we are taking into account situations where the env file is not loaded properly. So we're going to be doing if error does not equal nil, and I want to obviously assign this to error, so error equals to go.env.load. So if something goes wrong, we're gonna put fatal and message this to whoever is trying to load, to us, error loading.env file. Otherwise, we just continue with what we were going to do. And I know it's just like 4 annoying lines, but it's useful and easy to see when you are not loading properly your .env file, and you save yourself a couple of minutes from figuring out why sometimes your application is not working. So that's why we need to put that. So once that we have our .env file loaded, we're going to get our port value in the following way. We need to import the OS package. So there you go. .log could not import. I wouldn't worry much about this. Yeah, there you go. So I just have to save it. Okay, so port, we're gonna add the port to that. So now actually, what do I have? A print line. So I'm gonna delete this and I'm gonna put it here. So API is listening on port, and then I'll pass on the port variable. Okay, and lastly, I'm going to declare a server variable, which will be pointing to the HTTP library server struct. There you go. And within the server struct that the HTTP library provides, we need to pass an address. Now, I know some people may think, why do you do it like this and not just create the string? But apparently, if you don't write it in this way, you get multiple errors. So I just write it with the format springf. And then, okay, so we don't have a router yet. So I'm actually going to delete this line and put a to-do add router. So we're gonna have to do that later. But for now, it's fine. Lastly, we're going to return the server, and then just put, or more than put, execute the listen and serve method. Now, so that is our serve method. We want to also add everything that we need inside of our main function. So because we cannot before this tutorial I was actually adding the port as a global variable, but since you need the go.load function, well, I don't know if you can do it globally, but for now I have it declared twice here. Maybe a general function would be ideal, but I don't want to start experimenting in this tutorial, so I'm just gonna leave it like that. So we're just going to be repeating the loading of our .env, and then we can go ahead and create a config struct, where in our config we're going to declare the port, which will equal the os.getEnv port. So now that we have that, we are also going to get our DSN. DSN is just a string, actually, that is to connect to the database. I'm not going to do the connection to the database just yet. We need to do a couple of things before we get to that. So I'm just gonna leave that out. Well, I'm just gonna leave that as to do connection to DB, just so I don't forget. And then we are going to create our application struct here. So application, and I want to be referencing the memory address, so hence the ampersand. And I'm going to do config equal to config, and the models as before, I don't have them. Add models later. I can put here at to do also. Okay. Which currently we don't have this field, but later we will add that field. And then lastly, we're going to do error equal to app.serve. And then if the error is not equal to nil, means that we have an error and we want to log it. Fatal F? No, just fatal. Okay. And we'll pass the error there. So that is all we need to have our server running. So now what we can do is go ahead and do the make run. So now everything is automated. And as you can see, it says API listening on port 8080. That is perfect. It's working perfectly. And, you know, our server is listening on port 8080. Let me see if we can actually test this. So localhost 8080. And the fact that we see a 404 means that something is actually working. Otherwise, we would see like no connection or whatever. So that's a good sign. Obviously, we don't have any routes or whatever set up yet. So, you know, that's why we don't show anything. But yeah, the fact that we see that is a good sign. Okay. So we added our server creation. Let's see, what else do we want to do? Because I want to go this in order. I want to do this in order, sorry. Okay, so what we're going to be doing next is connecting to the database. So let's do the following. We are going to create a folder called DB. So let's go inside of the, well, actually within the coffee server level, I'm going to create my DB folder, and there I'm going to create my db.go file. So we're going to be doing the following. I'm going to create another struct, so type db struct, where it's going to be called db, and this is going to be pointing to the SQL db, probably a struct, and we're going to be using this library, which comes by default. I'm going to be also declaring the database connection, and that will equal to the memory address of our db struct. I'm also going to be creating three variables here, three global variables. These are going to be constants. So max open db connections. This will be 10 max connections. The max idle time, which will be fine, or sorry, max idle db connection, sorry, that will be 5. And the max db lifetime, and we're going to put 5 times time dot minute and max db lifetime. Okay, I believe we should be good with that. So now, and you're going to see how this relates to the following function. We're going to create a function called connect postgres. Could be connect postgres db, connect postgres, whatever, but I'm going to leave it as connect postgres. And we're going to return a pointer to the DB and an error. Obviously, if all goes well, the error part will be nil. I'm also going to declare a D, which will reference the database. So that D variable, that D variable will reference the database connection. And we're going to be using a PGX driver. And we're going to have to pass the DSN, which is the connection, you know, the local host, the user, the password, the port, and whatnot. That's what the DSN refers to. And you'll see how we will be using the DSN right now. So if there's an error, we will return a nil pointer and the actual error. Otherwise, we just go ahead and set that database connection of set max open connections equal to max open DB connections, D set max idle connections equal to max idle DB connections, and D set what was it, max lifetime equals to max DB lifetime, right? So we're just referencing these variables here in here. And rather than just put in 10, 5, and 5, this is just a nicer way to create to set rather the properties of our database connection, because here you can change it and then your code doesn't break. So it's just a nice way of doing it. You could possibly also just pass the numbers here, but you know, I think it's a good practice to set up your variables and then you just change whatever is above, and you don't mess with the inner code of the function. So here I'm going to make sure that we can test the DB, and you know, I'm gonna pass the DB driver setup. We don't have that function, so let's go ahead and create the test DB method, where this method will get the pointer to the SQLDB library. Actually, no, not library, sorry. We're going to be passing our DB connection setup. My mistake. And we will be returning an error. So if all goes well, that error will be nil. Otherwise, we do print that error. So we're going to ping the database, and you know, same thing. If it's not nil, format print the error. And we also want to return the error. Otherwise, we want to, so format print, there you go. We want to make sure that whoever is running the server, so ping database successfully, and we want to put that message. Then we just return a nil pointer. So then we can continue with the connection connect postgres method. So we have that same thing. If error does not equal nil, return nil error. Otherwise, the DB connection.db will set that equal to our D setup, and we will return the DB connection with a nil error. And there you go. So that is our DB connection setup. And now we can go ahead and go into our main file, and you know, here where I had the DB connection, we're going to do that right now. So for that, what we need is the following. We need to get the DSN. So again, the DSN, just to remind you, I'm going to open the .env. Okay, I don't have the DSN. Okay, let's write that. It's just, I'm going to copy paste it. You can also copy paste it from the GitHub repo. I'm gonna put it on the description so that way you don't have any errors. Okay, there you go, DSN. So again, we just put the host equal to localhost, port equal to 5432, the user, the password, the name of the DB. Now, very careful here. This is my other project, the one that I'm referencing, so it's not this. It's actually YouTube Coffee DB. SSL mode disabled, time zone equal to UDC, and connect timeout equal to 5. Okay, perfect. So we're gonna go back to our main file, and we're gonna continue with the DB connection setup. So the DSN, now we can get this from our .env. So this is the DSN variable, and we're going to assign it the DB connection to our DB, and this is not imported. Let's see. This should import automatically. Let me try one more time. DB, okay. So I'm gonna have to import it manually. You probably won't have a problem. For now, since I'm using Vim, it'll complain a little bit. Let me go to the Go mod. What did I put? YouTube. So I'm just gonna copy this. Go to the main. And paste. Okay. And get rid of this extra semicolon. Save. Then I'm gonna go down, and where did I have that? Okay, here. So let's see, db dot connect postgres. DB declared. Oh, one thing that I'm missing. This should have /db, I believe. Can initialize with value, connect postgres, DSN. Probably I need to get rid of this. The current name DB. Interesting. Probably I didn't put a. No, I am returning 2 errors. Let me close this. Sometimes Vim takes a bit to process. I'm actually going to delete this too, just to see if it automatically imports the DB package. So DB, no, okay. Server, DB, okay. It's not importing that. So github.com Arthur Fio. I'm actually going to copy this from Go mod. Okay, so let's go to the main. DB. DSN, and then let's see if it kind of goes to the. All right, that's strange, but let's continue. Probably you don't have this on VS Code. All right, so now it's pulling up the method. Okay, cool. So it's working now. Okay, so we have the DB connection there. So now we want to make sure that we don't get an error. And again, we want to lock that. So lock.fatal. And if something goes wrong, we are going to put cannot connect to database. We are also going to defer. So defer again, if you don't recall, actually, so I have a YouTube series on basics of Golang, and I teach you there what does defer, panic, and I'm missing the other keyword. But essentially defer, specifically defer. I explained how defer works, which is like the keyword that allows the process to run, and then at last it runs whatever line you have on that defer. And it's really useful, especially with the DB connections, where you want to be able to execute everything that you have for the DB connection. Then once you have all that executed, then you can defer to the DB connection close, as we're going to be doing here. So very useful using that defer. Okay, so once that we have that, then we have the application declaration, perfect. Then we have all this, the models, we don't have them created yet. So now let's go ahead and, I don't know why I always open a new one. Let's go ahead and make sure that this runs. So I'm gonna do make run. And okay, so we have an error, that's fine. And it says cannot connect to database. So at least it's good that we know where we have our error. So let me see if I have an error in the DSN. So I have to go into my .env. Here, DSN. Maybe I forgot to write it. Okay, no, so it's not that. YouTube coffee DB. Okay, so I don't think I have any typos there. Let's make sure the container is running. Okay, the container is running. So then we must have a typo in our DB connection file. So I'm gonna get my notes out. I just want to double check that everything is in order. So D an error equal to SQL open. Oh, of course, the imports, very important. We need a couple more imports that I did not add. So again, if you don't add this, you're gonna encounter the same error that I have right here. You're gonna see the error of connection. So we're gonna add that, and the JAX-C PG connection is a very useful library. So I'm just gonna paste this 3 times and I'll change the terminations. And then lastly, this one is going to be lib/pq. Okay, so this one, rather than pgcon, is going to be pgx version 4, and this is going to be stdlib. So now, again, I keep on opening a new tile, that's fine. Again, I'm gonna do go mod tidy, which will go and fetch those packages for me. stdlib, okay, so probably I have a typo there, std JAX-C pgx. Okay, so I'm missing the pgx. Okay, so now I'm gonna go again and do go mod tidy, perfect. Could I import? Okay, so I'm actually going to do right quit, then open again the db.go. I'm going to ignore this for now because this should be installed. And then if you want to double check, you can go to the go.mod and see the installations. So yep, we have everything there. So sometimes again, Vim can be like that. If you're using VS Code, you probably won't have any problem. And there you go. So it says ping database successfully. So that's great. So far we're doing great. Let me see how long it's been. Okay, 1 hour. Okay, so it's not, we have a good time. We're under good time recording this, so that's good. And the connection to the database is successful. So that is good. We can continue to creating our entities and the CRUD for the entities. In this case, this will be the coffee. We won't have more, not in this tutorial, but normally you have, for example, you have the users, you have whatever product you have, you can have categories, you can have orders and whatnot. So you can have multiple entities in your application. Again, in this case, we're only going to be doing the coffee entities. So let's go ahead and create those entities, or rather the coffee entity and the controllers, the any helpers that we need, the router and whatnot. So let's go ahead and do that. So the first thing that I'm going to do is create the services folder. Also, so I don't forget, I'm going to create the controllers folder. Services. Also, we're going to create the helpers folder. Helpers, services, controllers. What else am I missing? And the router. Okay, perfect. So we have all those folders, and those will be all the folders that we will be needing. We won't need to create any more folders. So now, coffee entries. Okay. Let's see. Yeah, we're gonna start with the services. Just looking at my notes, because I have like the guideline. Probably I wrote something funky there that now I don't understand, but all good. In general, it's all outlined. So let's start with the services. So here, I'm going to create a coffee.go file. This will be under the package services, and we are going to create our coffee struct. So this is going to have an ID of type string, and this is in order to declare how we're going to be looking at the information when we send it via JSON format. So that's why we declare it in the following way, and we're actually going to put it like that. Same with the name. So again, JSON string. Same with the type of roast. I don't know why I put string here. This has to have name. Then this has roast. There you go. Then image, same thing, of type string. Region, also type string, region. Price, here I'm going to put a float 32 because we only have a 64 and a 32, and for this particular case 32-bit field will be more than enough. And here I'm missing the semicolon, which the Go LSB is nice enough to let me know. I'm missing the colons there. Okay. Grind unit. So how fine do I want to grind my coffee whenever I create delicious espresso? So there's going to be a grind unit, and I'm going to separate it with the underscore. And lastly, we have the management type of field, created at and updated at. So created at time.time, JSON, created at, and I'm just gonna copy that and put updated at, and here same thing, updated at. And I don't think I want this weird time library. I want the normal time library. There you go. So now we've created our coffee struct. We're going to start creating the getAllCoffees method. So again, we're going to be pointing to our coffee struct and declare the name getAllCoffees. Now we're going to be returning a slice of coffee struct and also an error. So here on the return declaration, I'm going to put those two things. So again, a pointer, we're going to return a slice of pointers and an error. We're also going to declare our context and the cancel variable. So here we're going to be writing context with timeout context with timeout. I'm going to be passing the context and what no, okay, my mistake. Let's get rid of that. So let's put context. Okay, so it is with timeout, and we're gonna pass the context background and the DB timeout. DB timeout. Okay. So now this DB timeout, actually we need to pull it from another file. Currently I don't have that created. So before we continue with the get all coffees method, which here again we're gonna have the connection to the database, and we're going to be retrieving all the entries. I'm gonna go ahead and create the main.go file within our services. So package services, and here I'm going to create the constant DB timeout. And I forgot, let me get the notes. Constant timeout. Okay, so the DB timeout will equal to 3 seconds. So times second times 3. I'm also going to be adding this variable DB, and this is going to be a pointer. I'm sorry, this is going to be a type of pointer, of the SQL DB struct. There you go. So now here, the way I did this, and you can think of this kind of like the index.tx or index.ts or the index.js. This is going to be our index file where we're going to be exporting all our models for our application to consume that data. So that is why I created a separate main.go file. So very similar to the application struct, here I'm going to declare my model struct, and I'm going to add the fields of all the models that we are going to have in this application. In this particular application, we're only going to have one main model, which is the coffee model or the coffee entity. But we're also going to have the JSON response. Response model. Now, currently we don't have that. So just to get that out of the way, I'm going to write it here. So there's going to be responses, actually response.go. Here, I'm going to declare the package services also. And this is going to be a very short file. I'm just going to write the type, the struct type, which again is going to be JSON response. And here we're going to have 3 things. We're going to have an error field. So again, this is going to be displayed as so when we pass the JSON data. The message field, which again we're gonna write it like so, and the data itself, which is going to be of type interface, which in this case is kind of any, the any variable in JavaScript. And normally I don't like to put any, or in this case interface, in Golang, but because of the fact that the data can be coming in any type of structure, that's why in this particular case it's good to have it as it is. All right, so we have that. We have the main file. I may have some more. Okay, yeah. I'm also going to create a function that will create a pool of connections. So this is going to be func new. It's gonna get a pool of connections and then return the model connection. So you'll see db equal to db pool, which again is just assigning the pool to this db pointer, and then it will return the model's struct. All right, since that should change. Too many return values. Am I missing it? Oh yeah. I need to put here models. There you go. Okay. So we have that. Now we're good to go and continue with our coffee method. Okay. So this is going to be the get all coffees. Obviously, we don't have any coffees in the database. So for now, this method is not going to work. So it is why we're going to declare and create this method and the create coffees method. That way we can see how these two work in tandem. So again, defer, cancel. We want to cancel the connection once everything is done. So I'm going to be doing the following. This is going to be a select statement, and we're going to be doing the following. We're going to be putting every single field of the struct in the query, and it has a reason why this is done like so. So name, image, okay, ID, name, image, roast, and it doesn't matter that I mix them. It's totally fine. If I have here roast before and then here I have image before, it doesn't matter in this case. Region, price, grind unit, created at, and updated at. And this is going to be coming from the coffees table. So TX declare but not use, create declare but not use. Okay, that's fine. Now we're going to be doing the following. We are going to be putting the rows, right? So we're going to be getting rows of, whatever the database responses with, or replies with, sorry. DB query context. And we're going to be passing the database context or the state, because that's precisely what the context is the state of the database. And we're going to pass the query. Error declared but not used. Okay, that's fine. We want to make sure that we don't get any errors. So, your typical handling error code excerpt. There you go. I'm going to get rid of that so we have more space. And we're going to be doing the following. I'm going to create a slice of pointers. So this is going to be coffees. And the pointers type will be of type coffee. So this slice will be having multiple coffee pointers. And what we're going to do is for every row, so rows.next that we have from our reply, we're going to create a coffee var coffee. We're going to create a coffee struct upon that row and append it to our coffee slice. So we're going to be scanning each row field. So this is going to be the first one, coffee.id. So I'm going to copy paste this 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put the different fields. So we have ID, we have name, we have image, we have roast, we have region, we have price. Actually, I'm missing a couple, but that's fine. Or one more. We have grind unit, And then we have the created at and updated at. So created at and updated at. Okay. Error declared but not used. That's fine. And this is important that all these declarations follow this order, because that's in the order that we are going to be getting our rows. So just have that in mind, that this exact order should follow this order, or vice versa. This order follows the order of the query. So now that we have that, again, we're gonna be doing some error handling, making sure that we don't get an error. If we get an error, we want to return that error. Otherwise, we want to update that slice, passing the old state of the old slice, right? And the new value that we want to append, which in this case is the coffee right here. And we do want to pass the pointer, because again, this is a slice of coffee pointers, hence why we pass the address to that struct, which later, if you're interested why we use pointers, it's just cheaper to pass a memory address rather than the whole struct, and the application is faster. But I'm gonna make that video. I think I have it in Spanish currently, but I'll make that video in English, so you guys can have that. Anyway, continue with this method. I'm going to be returning the slice of pointers, which is the coffees, and nil error. And with that, we should be fine. So now we're going to go ahead and continue with the create method. So again, this is going to be a method which we declared in this way. So we point towards the coffee struct, and that's how we know this is a method. Now the name of the method will be create coffee. And actually, let me do that. There you go. And we're gonna be using the following. We're gonna need a coffee, data or body or whatever. We need to get that from somewhere. So we're gonna declare that value or parameter or argument in this way. And once we create that, we're going to return the coffee pointer and an error. So let's go ahead with the creation. Again, we want to get the context of the database. So context with timeout, and we want to get that context dot background. And also we want the context, also using the DB timeout. We're going to be using the defer cancel. And now we can go ahead and create our query to create the coffee. So to create the coffee, we're going to be using an insert. So insert into the table coffees with name, image, region, roast, price, grind unit, created at, and updated at. And the values are going to be 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we will be returning the whole row when we create that coffee. That's what the return star refers to. So now what we're going to do is assign just the error. We do need the two values, but we really don't care for the return. I believe I can put the response here. But if we don't use it, it'll complain. So actually, I'll put response there, and we'll see what happens. But I may be experimenting a little bit too much, so I'm just gonna put here, I'm gonna put check. So if there's an error, I know where to go to the check. But if not, I'll fix it and put it as I have it on my notes. So anyway, I'm gonna put an exec command. So we're going to execute our query. We're gonna pass a query, and also we're going to pass the fields that we get from the parameter of this function, right? Where this coffee is the one that we'll get here. So again, this has to be in the same order as the order that we have in the query. So coffee.name, and I'm gonna put 8 more times. So 1, 2, 3, 4, 5, 6, 7, 8. Maybe, yeah, 8, that's fine. So name, image, region, roast, price, grind unit, created at, updated at, and do I have one extra? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I have an extra. And by the way, rather than doing this, the created at and updated at, we're actually not gonna get it from the coffee.body. From the coffee body that we get. We're actually going to do time.now. So we're gonna be handling that internally, and that's a common thing. So that's how we're going to get the created at and updated at field. Same thing, if there's an error, we want to return the error. Otherwise, we return the response and the nil. That's the reason why I didn't do that. Okay, because this returns probably an SQL formatted, and probably we need to do more manipulation. So I'm just gonna put an underscore here, and then instead of .rest, I'm just gonna put the coffee. Now, mind you, this is not the coffee that will be stored in the database. This is just the information that we used to create the coffee. But if all goes well and we get to this stage, it means that everything went well and we saved a coffee with the information that we have here. So it's totally fine that we leave this method as it is. And actually, now I don't need to check anything because I know that the other way that I had it will give me an error. Well, not error, but will give me more unnecessary trouble. Okay, cool. So we have that in place. So now we can go ahead and start, adding the controllers, adding the routers. We also need to add the helpers because for the controllers we need to be able to retrieve JSON and also write some JSON and whatnot. So we're going to also create helpers. So let's see. Okay. All right. So let's go ahead and create the helper methods. So this is going to be a file called helpers.go. So package helpers. And here we're going to be writing the following. We're going to be creating a write JSON method, or rather than method function, a read JSON function, and also a couple of variables that will help us with that. So let's go ahead and do that. I don't recall using the envelope. This is a type of interface that helps structuring a response in such a way that it looks nicer, but I'm gonna write it in case that I need to use it. So I'm gonna put that there. Again, we're using the empty interface to allow us to have, any type of response / envelope, specifically when we use JSON responses. So hence the interface type there. envelope with an E at the end. Okay. We're also going to have a struct of type message, where it's going to have two fields, the info log, and this is going to be having this is going to be a type of pointer to the logger, and then error log, which will also have a pointer to the logger struct. Obviously, as you can infer, one will log just information, the other one will log errors. We are also going to declare two global variables that will extend the info log and error log fields in the message struct. So info log equals to log.new always.std out, and we're going to prepend the info log message with info, and we're gonna pass the date to the logger and the time, so L time, to the logger. We're going to be doing something very similar to the error log, so this is going to be error log. Now same thing, again, rather than info, this is going to be error. And also we're going to pass a log date and a log time, but additionally we're going to pass an L file, which is log L short file. And this because if we have an error, we want to know which file is the one that is having an error. So now what we're going to do is also create this global message logs struct. So message logs struct, which is going to be created upon the message struct that we just declared above, and the info log field will be assigned to info log, and the error log field will be assigned to our error log. There you go. So now what we're going to do is create the read JSON method, which will use the response and request. So http dot response writer and dr for request. So http dot request, and we also need to get whatever data we are receiving, right? Because if we're reading JSON, or if we're reading data, or rather reading JSON, we need to pass that in the parameters. So what we're going to do is declare max amount of bytes that we can read, and this is going to be in JSON. So I'm not 100% sure, but I'm 95% sure that this actually is standard of data that you can read in string, because again, JSON is just a string formatted in JSON fashion, hence in JavaScript fashion, hence the JSON, which is JavaScript object notation, but in reality it's just a string. So this should be more than enough to get any type of string. So 10, 4, 8, 5, 7, 6, and then the request dot body is going to be assigned, or rather than assigned, we're going to set that max bytes, so max bytes reader, to the max to the max bytes. I should put here max bytes. There you go. So we don't get that max byte. And okay, yeah, that's fine. Now we're going to put the decode as DEC JSON dot a new decoder. So we're going to decode whatever we get from the request dot body. Error, if there's an error when we decode that. So we're going to try to decode the data that we get. And again, if we get an error, we want to return it, and we also want to make sure not only when we decode it, but when we struct if io.end file return, but it must have an only single JSON method. Okay, so in case that we see like two, really this is just safekeeping, but making sure that when we parse the JSON, we don't have like two objects. So we're just saying, you know, if we see two open and closing brackets of the JSON, then obviously there's an error there. So if the error is not nil, in this particular case, we know errors.new that there's two JSON objects, which that is not right. Normally you just have one main object, and within that main object, then you can have attributes of that main object. So we're gonna put body must have only a single JSON object. So again, this is just safe housekeeping, or safekeeping. I forgot the proper phrase, but anyway, it's just like you know, managing reading JSON, which, you know, is important. So we have the read JSON. Let's go ahead and write the write JSON method. So this is what we are going to be returning. So http.responseWriter are you know, making the http.request, sorry. And actually I'm not going to need the request because the request is used in the read. So rather than using that, I'm gonna pass the status, what I'm going to be returning, which is, you know, of type empty interface, and also we're going to be passing whichever number of headers we need to pass. So I'm going to declare a variable out an error and set that equal to the Marshall indent. So Marshall, that's how you you know, convert into JSON. And I'm also going to tab the data structure in that JSON writing. Same thing, if there's an error and the error is not equal to nil, then we return the error. Also, if the len of the headers is bigger than 0, meaning if we are passing any headers, we want to set those headers. So for the key and value of each header, we want to write the header with the key and the value. I want to put range. Okay. So now that we have that, we're going to do write header dot set content type and application JSON. Okay. We're also going to write a header and put the status code, and then write all the data that we converted to JSON. So if we have an error, same thing, we return the error, otherwise we return nil. And mix name and unnamed oh, I'm missing the headers here. Naming headers. Okay, expected operand found if len headers is equal to 0 for header equals key value. Am I missing something? Probably I have a typo here, but I cannot see it. Let's see. Turn new expected operand. Well, I don't have anything there. Jesus. Wow. I don't know how I missed that. Anyway, there you go. So that is our write JSON. And actually I'm missing one more method, which is the error JSON. I guess that we could use the write for this, but since you know, we have a very particular use case, which is returning errors, I guess it's good to you know, create a specific error JSON method. So the status code will be equal to the http.status.request. If the len of the status is bigger than 0, then we'll set the status code equal to the first status code that we get. From here. And we are also going to declare a payload where we're going to assign the type to the response.json, so services.json response. And I want to see, what did I bring from service? Okay, yeah. We're going to obviously get the struct from our package services package, and the payload.error will be equal to true. The payload.message will be equal to error.error, and we are actually going to make use of our write.json to write the error. And there you go. Those are our helper functions, which we are going to heavily rely on. So it's very important that we create this before we go into the controllers. So now that we have that, we're going to go ahead and create the controllers. We only have right now one entity, which is the coffee. So we are only going to create one controller currently, but obviously if we would have more, we would create more. We don't really need main.go file in this case for the controllers, so we should be fine with that. So let's go ahead and start with the get coffees. Okay, so in order to make this a little bit simpler, I'm going to be doing the following. I'm going to be declaring, actually I'm gonna put this here. Okay, so coffee will be a variable that will contain the coffee struct type, and what we're going to do is make use of this coffee variable for methods and whatnot. You'll see right now. So we're also going to call this get all coffees. We're going to be having the response writer, our http.request, and we're not going to be returning anything not in this method. At least we're going to write JSON data, but you know, the JSON data will do its thing. We're not returning anything in this method. So we're going to declare all as all coffees and the error, and we're going to do coffee dot get all coffees, and also do some error handling. So if we get some errors, we need to log that message, and we're going to be doing messages log rather than info log fatal. We're gonna do messages error log, and then we're gonna be using the print line. And I know this can be a little bit wordful, but it's the only way that we can append the the error with the indentation and the file if there's an error and all that good stuff that our struct gives us. So we're gonna have to rely on this, and we're going to return. If all goes well, then we're just going to write the JSON with all the coffees that we get from the database, get or rather than get return HTTP status OK. And with the envelope, we are going to return the coffees as so. Missing key map literal. Let me see, probably map string interface. Map string type envelope. What was the controllers? Oh, it's not a comma. It's semicolon. Okay, my mistake. There you go. So we have the get coffees. Now let's also go ahead and do the create coffee controller. So same thing. This is gonna have the HTTP response writer and the request pointer. So HTTP.request, and we're gonna be let me put here the post coffees coffee. Here we're gonna put or rather than put declare the coffee data that we get from the request, and this is gonna be of type coffee. We are going to set that decoding to an error in case that there is. So we're gonna grab the request body and decode it and put it into our coffee data. If something goes wrong, again, we need to handle that. So we're gonna do helpers dot message logs dot error log and then dot print line. I know it's a lot, but again, it's helpful in that way. And then we return the error. Actually, we don't need to return it, we just print it. Otherwise, if everything goes right, then we write the JSON with the newly created coffee. So status OK, and we pass the coffee data. Now the coffee created will be equal to, right now we haven't done anything, which actually, to be honest, I'm gonna put here check. We should put the writing after the coffee is created, but I'll see right now if everything goes well. Anyway, so first we need to create the coffee. We want to make sure that that is created before we write it into the JSON. So coffee, create coffee, and I'm gonna put the coffee data, right? Because we're going to be passing, gonna use coffee, create coffee value of Coffee services, coffee data. Yeah, here, I don't know why I did that. It should be coffee created. There you go. So now what I'm going to do is, if there's no error, well, first do if error does not equal to nil, we're gonna put helpers dot message logs error log dot print line error, and then return. Otherwise, I'm going to do helpers dot write JSON http dot status okay, and then pass the coffee created. So this should be enough. I just want to see if there's no errors, because I did it a little bit differently from what I have it on my notes, but I think it should be fine. If not, I'll write it as I have it on my notes. But so we have the controllers created. Now the last thing that we need to do is create our router in order to see this in action. So let's go ahead and create the router. So we're going to declare the package router. And for the router, we are going to do the following. So we're going to declare a routes function. So this function will create and return the routes. And this is going to return a type of HTTP handler. So it's going to be returning that type of struct. So my router, I'm going to create it with Chi, because that's the router that I normally use. And I think it's a really good router. It's a router that mostly uses the standard library. So in case that you want to change it later, it's actually really easy to do so. So currently I don't have this installed. I can do later. I can do go mod tidy. So well, I can, I already wrote it, so go mod tidy. Probably need to save it. There you go. So now it installed the Chi router, which actually actually we're going to be using the version 5. Anyway, I'll deal with the imports right now. But first, let's do this. And it says undeclared name Chi. That error should go away, so I wouldn't worry about that yet. We're gonna do router.use, and we're gonna be using a recover. So recover, which also comes from Chi. It's not from, okay, so this is not from Fiverr actually. This should come from the Chi library. There you go. Chi B5 should be middleware. Okay. We are also going to be using the cores. So router.use cores.handler, and we're going to be passing the cores options, and we'll put that there. Now I'm gonna put again my GitHub repo, so you guys don't have to write this. It's really not worth writing this by hand. You can just copy paste it. It really doesn't add any value for you writing this specifically. Obviously everything else is valuable to write on your own, but this particular case, the cores options, not really. Obviously it is important for you guys to know what are you writing, but if you copy paste it, it's fine. So I'm gonna put that there again. So the allowed origins, the allowed methods, the allowed headers, the expose headers, to allowed credentials, and the max age of the course. Alright, so now that we have that, we can go ahead and declare our first routes. So I'm going to create my get route to get all the coffees. So this is going to be API/v1/coffees. And you may ask yourself, what is the reasoning behind the v1? The thing is that you can have an API and you change it and it completely changes the way you return information. But let's say that you have clients that rely on your API, or you have applications that rely on your API, multiple applications like mobile, desktop, whatever. So what you do is, in order for everybody to do a smooth transition, you leave the API version 1 working, and then you release the version 2. So then people can do the smooth transition, and you have both working at the same time. Then once everybody does the transition, then you can get rid of the version 1 API methods. And that is the reasoning why you put API/v1. You don't really need it. You don't have to put it if you don't like it. I just like to do it. But again, it's not really necessary. It's actually more for people that only provide APIs to third parties. In this case, this use case would be more for just our server, and our internal front end would be, or client would be consuming this. So it's not a big deal whether you put it or not. To create a coffee, we're going to do API/v1/coffees/coffee, and I'm going to pass the ID. There's a lot of people that think that this is redundant. Yeah, I mean, it's up to you. Let's do it this way. Let's get rid of the single coffee wording. And I'm gonna pass the create coffee method. And again, we don't need to do the opening and closing. We can pass it kind of like as a callback, right? And the controller already has the request and response writer declared, so we don't need to pass anything there. And lastly, we're going to return the router. So we should be fine with that. Now I'm gonna do go mod tidy to make sure that we have the chi libraries installed. I'm actually going to quit neovim to see if okay, so now we don't have those errors, but we do have the recover. This is actually recover error. So probably you need to change this too. Where else did we have? I think in controllers. Okay, we don't have any errors anymore. Okay, so we should be having everything good to go. The last thing that we're missing is adding our routers and models in our main file, because remember we had in the main server file. Remember we had the to-do things. So here we're gonna go ahead and now we're going to update this. So this field is going to be named models of type models, declare name models, and then we're just going to import the DB package and declare name models. That should be working. Let me see if I did something different. Oh, services. Okay. So sometimes Vim is not working with me, so I'm just going to import this manually from services. Oh, that's why. This is services.models. there you go. So we should have that in place. So now it should be working properly. Now also here the to do, I'm gonna get rid of that. On where we have to do, I need to add my router here. So this field is called, for the router, it's called a handler. And we're gonna be passing into our handler our routes. So we're gonna say router dot routes, because remember this router package is from here. All right, so we have that in place. We have the listener server. Let me see if I have another to do. Okay, so yeah, we need to add the models there. So I'm going to be doing in the in the application struct models, right? Because we changed the struct, but not the object that we created upon our struct. So we're gonna do services that new db connection db. So this is going to create a connection with the database to get the models whenever we want to, retrieve the coffees, create new coffees, update or delete. So right now we don't have update, delete, or get by ID, but we just want to test those two. So I'm gonna go ahead and write that change. I'm gonna do make run. I'm just gonna write it. Make run. Make sure that we don't have any errors. Okay, that's perfect. No errors. So I'm gonna open Postman. And we're gonna make sure that we can do the get and post. So so by the way, if the get is working, we should see the following: coffee is null. That's great. So it means that it is working, but we just don't have any coffees. So here I actually pre-added the data. We're gonna put the name, the region, the roast, the image, the pricing, the grind unit, and the created data and updated data will be created on its own. Same with the ID. The URL is going to be localhost 8080/API/v1/coffees. And actually, I think I miswrote something. This is not going to work. So yeah, so do I want to leave it like that? Yeah, that's why I probably left it like that. So there's two schools of thoughts. You can either do the following. Yeah, it's just that coffee, and then you can put like create. I'm just gonna leave it like that actually. So I like that way better. So coffee/coffee. Yeah. So we're gonna have to rerun this. So I'm going to re-execute our make run. It'll delete the binary, create the new binary, and run it again. And we don't have any errors, not that I can see at least. Just to make sure, I'm gonna run not this one, this by get ID, and we don't have this. This is me testing it prior to the video. All right, so it works. So now I'm gonna go back to the post, and I'm gonna write the following. Let's put. It was not EXO. It was. I don't know. Let's put Panther coffee, which is actually a really good coffee. And we get the okay. Now we don't see anything here. Hopefully I don't have any error. Okay, so now we do see syntax error at or near return. Now the problem here is that we have multiple coffee files, just to make sure that I didn't actually. Okay, not this one. All right, so we didn't write anything. Coffee.go. So 35. All right, so I believe it's not this one. This should be fine. I believe it's from the controllers. So controllers coffee 35. Yep. Coffee created. Okay, let me see if I have an error. I'm gonna see my notes. Coffee.go. Create coffee. Okay, so let's see. We have the variable declared. We have the decoded information. We have the error handling. This, okay. So what we need to do is, I am not 100% sure if we need to me it doesn't make sense that we need to decode and also write JSON in order to pass it into the create method. But let's see, because I did write this a little bit different. So let's see if that is the culprit of our error. http.status, okay, and I'm gonna pass the coffee.data again. Let's see, that's fine. Now let's exit. Okay, so it seems like so. It still says there's an error, so near the return. There's a syntax error. Okay. Interesting. So let's see. I'm actually going to do the get all coffees to see if okay, so it was not written into the database. Okay. Let's see. Apparently there's a syntax error somewhere here. Okay, so error helpers message logs error log print line error return. So far I see everything is working. In my opinion, this should not be happening, so I'm gonna get rid of this. What else? I want to do one more thing here. Second error check, and then yeah, this like the famous console log. Alright, so I'm gonna do make run. Oh, I'm missing a comment here on both. Okay. Alright, so I'm gonna rerun that. We're gonna see the error again. So it's in the second check. So it seems to be in the coffee data part. Okay. So so I've been checking the code, so you guys don't have to like see me going through the code. It actually didn't take me that long in this case, thankfully. But I found the error. It should say SQL error returning, and it was a little bit difficult because it says return, so I was looking for a return, but I should have seen, and I'm gonna show you guys. So it says SQL state. So I should have known that with the SQL state, it was an SQL related error, and I should have found that faster. Thankfully, it didn't take me that long, but yeah, that was the error. I had return rather than returning, which is the keyword that we need. If you don't have that, you're gonna get that error. So again, let's just make sure that this is working. So I don't have this method written yet. This one, sorry. So we have coffee's null is working perfectly, and then we're gonna post a new coffee, and there you go. We have the this ID. Let me see what I'm returning. And the controller. So the coffee created. Okay, so I'm returning the coffee created. Yeah, that's perfect. And I'm gonna get rid of these console logs. So even though we don't have the ID because the ID is generated at the time, this should be working now. So if we make this request, as you can see, we'd see the coffee with the actual UUID generated and the proper date for the created ad and updated ad. So let's go ahead and create another one just to see the get method working also with other with another coffee created. So I'm gonna call this, I don't know, Lavazza, and I believe that is made in Italy. Again, no image, price, that's 11. Grind unit, I actually use 5. And there you go, Lavazza, medium, no image, Italy, etc., etc. Then here, then we should see both the Panther coffee and the Lavazza. Perfect. So now we have our application working perfectly. We have almost everything in place. The last thing that we need to do is create the get by ID, update and delete. So we're gonna go ahead and start with the services and create those methods. So let's start with the get coffee by ID, which is very similar to get all coffees. It's just that we don't loop through the rows. We only get a single row. So again, this is an extension of the coffees struct. So get coffee by ID. We're gonna get an ID as a parameter, and we're going to be returning a coffee pointer and an error. So again, we gotta pass the context, and then later we cancel the connection context with timeout. We need to get the context background or the state of the DB with the timeout declaration that we did. Then we do the defer cancel, and then we create our query, which is select. Then we do the same thing that we did here. So actually I'm going to copy all of this, go down here and paste it, and let me put that there. There you go. The only difference is that I'm going to do from coffees and also at the where ID is equal to 1. So that is the only difference. And I'm going to put that there so it looks nice. Then we can go ahead and create our coffee struct that we're going to be returning. And then we're going to get a single row. So we're going to do db.query. We're actually going to do query row context in this case. So let's do query row context, where we are going to be passing the context, the query, and the ID. And then within the row, we're going to be scanning, and also I can copy this from the get all method above, so I can do the following and get this from here. So I'm gonna copy that, and I'm gonna go to the line. Whoa. Here, sorry, got a little bit lost there, but there you go. So remember, inside of the get coffee by ID, where we're doing the scanning, and let me indent this actually the other side. There you go. Okay. And we need to pass the, oh no, we don't need to pass the ID because it's already there. It's already there, yeah. Okay. So we're gonna scan that row into the coffee variable that we just created. Make sure that we do our proper error handling. So return nil and error. And then if all goes right, then we do a return and the memory address to the coffee we just created. That we just got. Found. Oh, very important. And also very important. Okay, there you go. So we have no more errors. Before I go ahead and create the controller methods, I'm gonna go ahead and also create the update and delete. That way we don't need to come back to this file. So let's go to let's go ahead and write that. So func c coffee updated coffee, should be update, not updated. And let's put this a little bit higher so it's easier to see. ID string, body of type coffee, and we're going to be returning a coffee pointer and an error. So again, we are going to declare the context and the cancel clause. Context with timeout. We're gonna get the context background and pass the db timeout. We're going to cancel the connection later, so we're going to do a defer cancel. So now we're going to do the query and update coffees. So we're going to update the table and specifically a single row. For that, we need to set the name to the first value that we have, the image, the roast, the price, the grind unit, the region, and the updated at. We obviously we don't need to update the created at. And that row is going to be updated where the ID is equal to whatever ith value we pass. And again, returning everything. So after that, we create our, or rather than create, we execute our query where we pass the context, the query, the body.name, and let me copy 1, 2, 3, 4, 5, 6, 7. The ID we pass there. So body.image, body.roast, body.price, body.grind unit, body.region, and the updated at, we actually are going to be doing a time.now, because at that precise point in time, was when it was updated. And then the ID. Also, again, our proper error handling, and return that if there's such error. Otherwise, we return the body dot new. Again, I could put the response here, get it from the SQL, parse it, return it. It's just too much work, unnecessary work, where if you get to this point, it means that your process was done correctly, and hence you can just return the body. So that's why I'd rather have the code as it is. And then lastly, we're gonna have the delete, which is actually really easy to do. So coffee, delete, coffee, ID, string, error. Again, we need to declare the context and the cancel, where this is context dot with timeout. And we want to get the context from the background, and we're also going to pass the timeout, cancel the connection. And then the query is very simple. Delete from coffees where ID is equal to 1. Probably didn't need backticks, but well, there they are. And then we execute the query and we pass the ID. Lastly, make sure that there's no errors. Return the error, otherwise we return nil. So there you go. That is all that we need for our services. So now we're gonna go into the controllers. So I'm actually gonna put here the get coffees, coffee, and I'm gonna put here ID. So func get coffee by ID w http dot response writer r http dot request, and let me check this out. Okay, so the way that we're going to get the ID, which is from the URL, is going to be in the following way. So g.url param, so from the URL parameter, and we're going to set it equal to whatever we get on the request, and the parameter is going to be called ID. So if we put this like, I don't know, val, then this would be val in our URL. But since it's ID, we're going to leave it like that. Now, the coffee that we're going to be getting is going to be done in the following way. Coffee dot get a coffee by ID. We pass the ID. We do error handling as always. And we want to make sure that if there's an error, we get the error and we print it. Otherwise, we return that JSON. So helpers dot write JSON with the right param that we declare, http dot status okay, and the coffee that we got. Okay. So now let's go ahead and create the update method. So coffees, coffee ID. So this is func update coffee w http dot response writer r http dot request. And same thing, we need to get this with the g.url.param. Same thing, the way we'll get the ID, bar coffee is equal to, I mean, we declare it as of type coffee. So what we're going to do first of all is get the values of the request.body. So JSON new decoder r.body. We're gonna place that into our created coffee variable. So coffee. Once we have that, we want to make sure that there's no error decoding this. So if there's an error, we want to know. So http.error, and we are going to put that inside of an error, and make sure that we display that it was a status bad request, and return. Otherwise, we are going to go ahead and continue with our update of the coffee updated. So coffee.update coffee, we're gonna pass the ID and our declared coffee. Coffee, okay. Now I know that you are seeing like, hold on a second, didn't this got declared all the way at the top? And it did, but actually we could even get rid of this. Since we already have it at, above, it should be fine. Actually, just to not get like confusions, I don't think there's anything wrong with that, but let's do coffee data. So this will get from services .coffee. That way it's very clear that this is the coffee data that we're trying to update. Very similar to the creation method. So coffee data, there you go. And now, same thing, we want to make sure that everything goes well. So if the error is not equal to nil, then we do helper helpers.message.errorlog.println, and then we put the error there. Otherwise, then we do the helpers.writeJSON http.status okay, and we put we pass the coffee updated. And lastly, we'll do the delete method, so coffee, and also pass the ID. And this is also a very quick controller to create, so delete coffee, again, http.response-writer, our http.request. We need to get the ID from the chi.url param. Again, we want to make sure, we're going straight into the deletion, so coffee.delete coffee, we pass the ID, we do our error handling, http.error. So actually, this shouldn't be an HTTP declaration. This will be actually easier. We do helpers.messages.errorlog println, and then we pass the error. There shouldn't be any error with this. And then lastly, if all goes well, we do helpers.writeJSON write http.status okay, And then rather than passing a struct, we just do successful deletion. Perfect. So then the last thing that we're missing is adding those methods here. So I'm actually going to copy that, and here I'm going to put coffee / ID. Here I'm just going to do get coffee by ID. I'm going to do here now the put coffees and pass the ID again. Then this is going to be update coffee, and lastly this is going to be a delete method, and I'm going to put delete coffee. So just make sure that you have the methods correctly written, but those are our methods. I don't need to pass anything else. Everything is already appended as it should in the main file. So now the only thing that I need to do is run this again, which will delete, compile, build again the binary, execute. So now we can go ahead and test this. So we can get our coffees. We can create a new coffee. So I'm going to put here in the creation, delete this. So here is the new coffee called delete this. Obviously, we'll delete that later. I'm gonna grab the ID. So now this route that we haven't used yet, localhost 8080 API v1 coffees coffee, and then I'm gonna pass the ID newly created. And there you go. We get the delete this coffee. Now let's go ahead and update it. So that's the only thing currently. We're gonna have to pass all the values, and obviously the ones that we don't want to update, we just pass the old values. But the ones that we do want to update, obviously we change them. We don't need to pass a created or updated, so we'll get rid of that. And delete this after update. And okay, we have null. Let's see if there's no error there. Okay, so there was an error. Let's see. SQL state. So now I know it's in the SQL state. Okay, so let's go to the services coffee.go. Let's go to the update coffee method, and I'm missing the commas. Very important. Maybe you caught this, maybe not, but if you didn't, well, now you know why it didn't work. Here we don't need a comma, so you can leave that without a comma, but these are necessary. So I'm gonna go ahead and recompile and re-execute. So just to make sure that we are getting the data, I'm gonna do get by ID. Okay, so still we have to delete this coffee. Then here I'm gonna put delete this after update. And now we get the proper response. Delete this after update. Perfect. So now I'm gonna go ahead, go here, make sure that we have everything. So we have delete this after update. Perfect. So I'm gonna delete now the coffee. Successful deletion. Perfect. Probably I should put like message. I don't know, maybe pass an envelope. That way it's easy to get, because otherwise if you get a string it may be a little bit hard to get. So let me see. Controllers, coffee.go, successful deletion. Or where did I write the envelope? There you go, helpers envelope. So I'm gonna put envelope, and I'm gonna do message, missing common argument list. helpers.envelope. What am I missing? Helpers.envelope. Coffees. Oh, okay. So I actually need to put this in quotes. Message. Let's see. Just trying to make this look nicer. So actually, I should be able to do. Let me see if I can do that. Okay. No. Successful deletion. Okay. Oh, wow, that was it. Actually, let me see if I can write it here. Successful deletion. There you go. So I'd rather just put it there. Okay, so I'm going to API listed import interrupt to copy that goes 77. Okay. Maybe I have an error in the deletion. Let's go ahead and do get all coffees. Yeah, so I have delete this. Okay, so apparently I had an error. So before I continue, let's go to the delete coffee. Delete from coffees. Yeah, I'm missing the where ID is equal to 1. And I guess that you can do this. That way it's easier to visualize where you have the error, because then it'll tell you in line 1, line 2. I don't know. I'll just leave it in 1 line, to be honest. I think that's fine. I do want to see if it's specified near the 1. Yeah, so it tells you like near where you have the error. So that's fine. So again, I'm going to recompile. And let's make sure that this last method works. So delete this after update. And there you go. Message successful deletion. So let's make sure that we don't have this coffee anymore. And there you go. It's deleted. Perfect. We're done with our API. And instead of 4 hours and who knows what, I think I shaved off 2 hours. Also, I did a little bit of refactoring. There were a few methods that I didn't like how they were. And the make file, I also updated it with the way that I thought that it was easier for you guys to follow. So please give it some thumbs up, subscribe, please share this. I think this is very useful. You can use it to, expand this and whatnot. So please subscribe, share, like, and yeah, keep watching, and I'll see you guys on the next video.